Hello! I guess it's recording. Can you hear me now? Anyway, that's from an old cell phone commercial. Okay, we better start the video. Okay, we're looking at vectors here. Are you looking at vectors? So vectors, Pythagorean theorem, SOHCAHTOA. Ta-da! Anyways, so the notation is new. So sometimes the vector, you see the letter V over here with the little arrow on top of it. Sometimes the V will be bolded and you won't have the arrow. Sometimes you can see I kind of used a half arrow. That's how I learned it. Sometimes it's the full arrow. On the right, you see the pointy brackets. So that is the new notation. The pointy brackets A and B in this form is called component form, and it basically represents a vector that started at the origin and ends at the point AB. But as a vector, it's the pointy brackets like that. A little bit to the right again, you see the double vertical bar. This indicates the magnitude. Now I was going to have it open, but I'm slow. In the lab manual and or on WebAssign, sometimes you see just a single vertical bar, and occasionally students mistake that for just absolute value. I'm going to try to find an example on the WebAssign that uses that while I hide the answers there. So yeah, right here. So you can see that V is kind of bolded and has the single vertical bars. So just be careful. It means magnitude, which is the length of the hypotenuse. Don't just make everything positive. That's why I like the double bars. And you can see on the right just the Pythagorean theorem right there. The vectors also have their direction angle, which is an angle in standard position. And we'll use the calculator to figure that out. So in the week 6 solving videos, I talk about my little chart that I've got here. So you could watch that again if you need to. So basically when you go to the calculator, make it positive. So magnitude up top here, Pythagorean theorem, direction angle, just make it positive and treat that as the reference angle alpha. And you can see each of the 4 quadrants. Once you have that reference angle, you just do one of those add subtract things to get the actual correct angle. I think my email just chimed there. Let's turn that off so it doesn't do it again. Also, when we do vectors, we are in degrees. So make sure the mode on your calculator is degrees. When you're solving, typically you solve with radians, but when you do vectors and the triangle things, law, sine, law, cosine, you want to be in degrees. Okay, let's take a look at an example. So you see my vector here just kind of out in space. It starts at the point 1, 3. It ends where the pointy bit is, the arrow, -4, -3. We're going to do 4 different things. We're going to write it in component form. That's with the pointy brackets. We're going to write it with what are called unit vectors, I and J. And these are alphabetical, so I is in the X direction, J is in the Y direction. Easy peasy. Magnitude and direction angle, we're going to finish it up. So to take the 2 points, a vector floating in space, and rewrite it as a vector starting at the origin, going to its end point, you're just going to take the x's and subtract and the y's and subtract. Take the end, the terminal point, and subtract the initial or starting point. So -4 minus 1, that's going to be -5. My little delta x is just fancy for how far apart are they. You want to keep the negative though, because the negative tells you kind of the direction that it's going. Likewise for y, -3y at the end, minus the +3y at the beginning, -6. So you can see part A, component form, pointy bracket, -5, -6, which is in quadrant 3. We need to pay attention to that. And then part B, the I, J unit vectors. Don't mix and match. If it says component, pointy bracket, do not use the I and J. If it says use the I and J, then don't put the pointy brackets. Part C, the magnitude, Pythagorean theorem. X squared plus y squared, all square rooted. Boom, right there. Part D, the direction angle. So again, we're going to take the x and y, -5, -6, make it positive so that the calculator gives us the reference angle, and then pay attention to the fact that this is in quadrant 3. So quadrant 3, 180 plus the reference angle. So the direction angle, 230.19. You got it right there. All right, next example, a little bit different. We're given the magnitude and the direction angle, and we want to write it in component form. SOHCAHTOA. So we did the TOA with the tangent, and now the x and y are the SOHCA, like that. You can see what I did. Make sure, I made a mistake in class because I wrote sine on the left. I wrote it below in my vector, but x is always first and y is always second. So the x component, 72 cosine 120 degrees, -36. The y component, 72 sine of 120 degrees, 36 square root of 3. Just like, and I just typed that straight in the calculator. Okay. The last thing that you'll see for this vector basic stuff is a word problem with a box on a ramp. And we're sometimes asked for the horizontal component, which is x, or the vertical component, which is y. Other words you might see are normal or perpendicular, which is horizontal, which is x, and parallel, which is y or vertical, and x goes with cosine and horizontal, and et cetera, et cetera. So part A, the normal component, 20 cosine 10, boom. Now be careful if you have an angle in quadrant 2, these are always positive. So I think at least once on WebAssign, you've got something where it's 127 degrees or something like that in quadrant 2, but all the answers are always positive because they're a force. We're given units for this, pounds in this case, so just be careful about that. That is the end of the basic stuff on vectors. We do more with vectors in a couple of weeks, but for now, we're done.